everyone, I am going to go over the periodic table, in particular groups and periods. Okay, so the periodic table is composed of elements. We've already talked about this. Arranging in order of increasing atomic numbers. So as you move across the periodic table, it'll go in numerical order. And as you go down, it will also increase in number. Remember, our atomic number is the number of protons that are in that element. So if you look at the top, it'll either be in the top left corner of each of the squares or top center. It just depends on the style of the periodic table that you get. Okay, this one, these two rows down here, they're actually a continuation of these two rows right here. If you like made a cut in your paper like around here and stick these in, you'd have a super long periodic table, but we'll talk about that later. Okay, the periods of the periodic table, these are the rows, okay, going down like this, not the columns, but the rows. Again, they are called periods. We have talked about this in class today, or we've talked about it in class, where the period tells you how many orbital shells or rings or energy levels or whatever you want to call them that atom has. So if I have an atom here in period 4, then I know that it's going to have 4 rings, orbitals, shells, energy levels, whatever you want to call them. They're all the same thing. Okay, groups, on the other hand, here, I'll scoot myself down here, are called families, but we will also call them groups. Elements in the same group will have the same number of valence electrons. We haven't really talked about valence electrons, but we have talked about electrons. This is going to be the number of electrons in the outermost energy level, or the shell or ring, or whatever you want to call it. So everything in group 1 will have 1 valence electron, whereas everybody in group 15 will have 5. We're going to ignore this 10 here in the middle, because when we start adding electrons in to these, they don't like to behave by adding electrons to the outermost ring. They'll start adding some into the innermost ring. It gets into a lot of science and a lot of difficulties, so we're just going to kind of skip over that for now. But yes, the valence electrons, this is going to be very, very, very important when it comes time for bonding. Because these are the guys, the valence electrons are the ones that rule the world of bonding. So they're very special in chemistry. Okay, you have 3 types of elements. You have metals, nonmetals, and these lovely things called metalloids. Metalloids are going to be kind of like somewhere in between metals and nonmetals, so they'll have characteristics of both. If you look at either the periodic table that's on the wall or the periodic table that you have at your desk, you'll either see a thick line that looks like a stair step, and so that's what I'll call it, as a stair step. And usually always all the atoms that touch that stair step are pretty much going to be metalloids. The obvious exemption is going to be aluminum, which is right here, but that should be kind of common sense. Like, aluminum's obviously very much a metal. It's not kind of like a sort of non-metal, or kind of like a metal, kind of like silicon is, but it is definitely a metal. But there you go. Okay, metals. They are typically very shiny. Most of them are on the harder side, except for the ones that are further to the left. Like sodium is actually a soft metal. You can cut it with a butter knife. But they have a lot of good electrons, and that is why having those electrons that are kind of like loosey-goosey, they're kind of like, oh, I want to be in this energy level. No, I want to be here. That's what makes them good conductors of electricity. And obviously, they conduct heat very well as well. Nonmetals, these tend to be soft, brittle. A lot of them are going to be gases. And they do not conduct heat or electricity very well. So an example, if I'm walking across the room and I pass like an electrical outlet, notice that the air doesn't conduct electricity and shock me. It's kind of an insulator. And that's what another word for poor conductors is going to be. Last one is going to be metalloids. Again, they share properties of metals and nonmetals, so they're going to be kind of somewhere in between. So this is a picture of the groups that we typically stay around. This is kind of like an old-fashioned one where each of these have a specific name and a specific characteristic. Some of them are still true, like this first column, the second column, this 10 here in the middle, and then the last two are pretty much going to have like a special name. But when you get over to here, when you have a lot of metals, nonmetals, and metalloids all together, we will separate them differently. We will look at this at a little bit later date where it actually makes sense. So you'll follow my rules. You won't follow this when we actually get to coloring our periodic table. Okay, alkali metals, extremely reactive with water, extremely reactive with just about anything. You in nature, you are not going to find this guy just hanging out by himself. He will be bonded with something else. And I forgot to tell you, going back here, there is one non-metal that's on the metal side, but it's because he has one valence electron as well. So this is hydrogen. And so even though he is part of the alkali metals, he's not really a metal. He is a clear gas that's a nonmetal. Alkaline earth metals, they are harder and shinier, where the alkali metals, remember I said sodium is right here, lithium is right here. These are going to be very soft metals. These are going to be harder metals, but they're still going to be very shiny. They're pretty reactive, but not to the level of alkali metals. So here you can see an example. Here's an example of sodium. You see that this is like a knife that it is just cutting into it as well. Transition metals, we are going to largely ignore this when it comes time for electrons and stuff, but they're going to be strong metals, and they are ductile. Ductile is just a fancy word for stretching it into a wire. And malleable means can you hammer it into a sheet like aluminum foil. And wire, like in the wires that are running through your Chromebook. They're also in the charging cords and all that kind of stuff. So yes, all of these can definitely be made into, they're ductile and malleable, and they will be made into coins and tools and used as wires and all that kind of stuff. Okay, again, this is kind of an old-fashioned way of doing 13 through 16, the boron, carbon, nitrogen, and oxygen family. The way that you remember these, and I will not be testing you on this, is that the very first atom in each of these is going to be your family. Again, we will be coloring the periodic table a little bit differently, where when we get to this 4-column section, we're only going to be looking at kind of turning them into 3 groups: metals, nonmetals, and metalloids. So you don't really have to remember that part as much. Okay, so you have carbon. Carbon looks can look shiny, and so that will be in this one. No, it's this one. Carbon is here. Nitrogen is next to it. We'll have oxygen here, and boron would be there. But honestly, again, I'm not going to test you on that one. Now these are more important. Halogens, this is group 17. They are extremely reactive elements that typically form a type of salt. The salt that you are typically used to is sodium chloride. A lot of people take a shortcut because they're lazy and just call it sodium, but it's not just sodium. Sodium is a very soft, shiny metal, but sodium chloride is what we are more used to. So people just shorten it to sodium. Anyway, so these halogens are going to be just as reactive as this alkali metal group. And they will bond with a lot of things. Noble gases, this is going to be, let's see if I can move myself up here. There we go. So noble gases, the reason why they're called noble gases is because they're the nobility and they don't interact with us peasants over here. Okay, so you can be around them all you want, but they will not create a bond or a reaction or anything like that. So like when you breathe helium, It can be dangerous to breathe nothing but helium, not because helium is harmful, it's because you're not breathing oxygen. And that is where you get lightheaded when you breathe helium. It's because you're just not getting enough oxygen. It's not reacting with you. But there you go. A lot of them, we will be using them in signs like neon or xenon. They will be, so we'll typically use them in neon signs. The lanthanide and the actinide series, these are the ones that are down here. Again, they typically, if you make a cut right here and stick these in, that's where they kind of belong. These are metals as well. They're also known as rare earth metals. And the reason why we pull them out and stick them down here is because they're really radioactive. And so we will not be playing with those. And so only special scientists get to interact with those. And so that's why they're kind of pulled out and put here at the bottom. But anyway, that should be about it. Hope this helped y'all.